Welcome to EDU World Space.
All right, my favorite kind of question. Where there's no numbers. So this is basically a generalization of the previous question. You have a puck, it's on a table, its puck's rotating around about the center of the table, and then you are pulling the puck in with a rope, and you want to get first the puck speed as a function of r. So as I discussed in the previous video, angular momentum is conserved so in general for some let me just write that down, actually. So you write for all points in time, you can say L initial is L final. So if it's at some radius R1, actually, what are the givens of the problem? So we're given an R initial and then a V initial. Okay, so initially the angular momentum is R cross P, R initial, V initial, and as I discussed in the previous video, R and P are perpendicular, so we don't need to worry about an angle. And then the final momentum is going to be some R V. So then you can get that the final V is equal just to, or like this V is equal to R initial V initial divided by R, just plain R, not R final. And next we want to get the tension in the cord as a function of R. In general, the tension is going to be mv squared divided by the R. But then what is the velocity as a function of R? We can sub in this for here. And so we can say it's m square this whole thing. So R initial squared, V initial squared divided by R squared, and then multiply it by R again. So you'll have an R cubed. Oof. And now you want to get the work done. So work is change in kinetic energy. So change in kinetic energy is 1/2 V final squared. So that's R initial V initial over R squared minus, final. And then you want to do minus initial. And so the initial velocity is just the initial squared. And suppose you can simplify this. So 1/2 V initial squared times R initial over R squared minus 1.